Hey YouTube, this is Austin Allen. I wanted to go over a brief project I recently completed for a client. It's a small male USB-C edge mount breakout board for connecting to some custom soldered cables. Here are 20 boards that I designed, ordered, and assembled by hand. The client required that this board be as small as possible to best fit within their application. This is the KiCAD schematic with the USB-C connector on top and the solder pads below it. USB-C connectors are inherently symmetrical, and since this particular connector is 24 pins, only 12 breakout pads were needed for this board. I selected the connector based on the parts that the board house, which is JLCPCB, had in stock. Here's the JLCPCB listing for this particular connector from Shohan. It's an edge or clamp style connector, meaning that it connects to the edge of a PCB. Here's the corresponding datasheet from JLCPCB's listing. What I wanted to confirm here was, number 1, the required PCB thickness, which is 0.8 millimeters for this connector, and number 2, the dimensions and geometry of this connector, to ensure that the total board size was sufficiently small for the client's needs. To set the number of layers and the total board thickness in KiCAD, navigate to the File and Board Setup menu and specify the copper layers number. The board thickness value near the bottom of this window confirms that this board will be 0.8 millimeters thick in total. This is the generated CAD model for this breakout board within KiCAD. I created a custom footprint for the vendor, Shohan, with the 3D model as given by the vendor. This model can be exported as a step file and viewed in a CAD modeling program like Fusion 360 to check the total dimensions. On the JLCPCB order page, after generating and uploading the Gerber files for this board, specify that the number of layers is 4. In addition, specify that the board thickness is 0.8 millimeters, not the standard 1.6 millimeter thickness. For this board, I also set the solder mask to be black with a white silkscreen because I think it looks good. JLCPCB has a board panelizing tool and an assembly service, but even when panelizing the boards, the total size of the boards didn't meet their minimum requirement for their assembly service, so I ordered the USB-C connectors separately from LCSC and assembled the boards myself. To assemble the boards, first apply No Clean Flux, this is Chip Quick brand, to the pads, and position and align the USB-C connector as well as you can on the board. I used an Omnivise to hold each PCB as I soldered them one by one. I used a technique called drag soldering with my soldering iron to solder the pins of the connector to the board. This typically creates solder bridges, which can then be removed using solder wick. Finally, I performed an inspection of the assembly quality. It's sufficient for being hand assembled, and can be cleaned up further using isopropyl alcohol or IPA and a swab. These breakout boards are ready to continue to the next phase for the client. I'll solder the custom cables for the breakout pads and add UV cured epoxy strain relief to help prevent the solder joints from breaking. All the tools I used for this project are available in the video description if you are in need of this equipment to do this sort of work yourself. Thanks for watching, and see you next time.